Good morning, everyone. So here are the notes for today, November 5th, 2024. And you guys, this is just a continuation of another day of what we were doing yesterday with the fundamental theorem of calculus part 1. Okay, except what we're going to do today is we're going to extend it to piecewise functions. So piecewise functions. So a little bit of review from what we did yesterday. So remember, something is called an indefinite integral. Indefinite integral. If it doesn't have bounds, so if there are no bounds. So basically, what does no bounds mean? That means there's not a number here and there's not a number here. And when you have an integral like that, you're always going to have that plus c at the end, okay? But if you have a definite integral, okay, that will have bounds. So this has bounds. So for example, you could have something like integral from a to b where there's actual numbers there. So if you have that here, the c goes away. Now remember, you guys, from yesterday, it does not go away magically. It actually, when you plug it in, the c's cancel out. So plus c if there are no boundaries, and you don't have a c if there are boundaries, okay? And you guys remember, this just right here, translation, this just means area under the curve from x equals a to x equals b. So that's all that really means, all right? So let's look at something here really fast. Let's look at an example, something that we kind of did yesterday, and I want to show you a cool little trick that you can use if your numbers get really, really big, okay? So let's say I have the integral from -2 to -1 of 6x to the -2 dx. Okay, so what I need to do first is I need to take the integral of this 6x to the -2. Now, you guys, warning, this thing is going to be really ugly, okay? So I'm going to have 6x to the, if I add 1, -2 plus 1 is -1, and then I divide by -1, and I'm evaluating from -2 to -1. Remember, that line is just called an evaluation bar, shows what you're evaluating from. And you guys, I was watching some people do the homework yesterday, and they're not putting this part of it in there. You have to show that, okay? So how do we do this? Well, when I look at this right here, I think, hey, that's pretty ugly. I don't want to be plugging in numbers into there. So let's fix it up a little bit. The first thing that I can see that maybe I could do is take this negative exponent, move it back down below, and make it a positive exponent. Let's try that and see what we get. So this is going to be 6 over -1, and then x to the +1 evaluated from -2 to -1. Okay, now you guys, again, it still looks kind of funky. What is 6 divided by -1? That's just -6. So really, I can just write this as -6 over x evaluated from -2 to -1. Okay, so just doing some algebra on this, making it a little bit nicer. I don't want to plug numbers in if there's a negative exponent. That just looks too darn ugly. Okay, now just like we did yesterday in class, we're going to do top minus bottom, right? You want to do the top minus the bottom. If you were not here, here's what that means, okay? That means take this -1 and we're going to plug it into the x. So that's going to give me -6 over -1. And then minus the bottom means take -2 and plug it in for the x. So it's going to give me -6 over -2. Now, you guys, there's a whole bunch of negatives in here. Let's see if we can make it a little bit nicer. -6 over -1 is just +6. Minus, and then -6 over -2 is just +3. And then we get 6 minus 3 is 3. So basically, what did we just find? If you took the area under the curve here, you would get that it equals 3. Okay? All right, now what about if we have that piecewise function? So example 2. All right, what if we have piecewise functions? Remember, those guys look like this. You have f of x equals x squared when x is less than 2, and then maybe 6 minus x when x is greater than or equal to 2. And the question is, find the integral from 0 to 4 of this function f of x. Okay, now first of all, like, what the heck is going on here? What does this even look like? So you guys, what you should notice here okay, is that we've got two functions here. This one is just a parabola, okay, but it only exists when x is less than 2. So let's put the 2 on there. So maybe it looks something like this, right? And it stops there. It keeps going to the left, but at the right, it just kind of stops. Now, what does the other one look like? 6 minus x. So when x is greater than or equal to 2, you guys, that's just a line with a negative slope. So it looks something like this. Does that kind of make sense? So this is what your graph looks like. Now, is it drawn exactly perfectly right? No, probably not. That's just a rough sketch, okay? Now, what is the question? The question is evaluate the integral from 0 to 4. So I only want the area under the curve from x equals 0, so I want to start here, to x equals 4, and I want to end there, okay? So what you need to find out is where does f of x split? Okay, so where does one function turn into another? You guys, it happens right here at x equals 2. So wherever it splits, you guys look here at the x equals 2. At x equals 2, this is the end of my parabola, and this is also the beginning of my line. Do you see that? So that's where it splits. So what I need to do is wherever that function splits is where I'm also going to split my integral. So check this out. I'm going from 0 to 4. Right? And then I'm going to split it at 2. So I wanted to find the integral from 0 to 4, but it's going to split at x equals 2. So let's write out two separate integrals and then actually do them. So I'm going to get the integral from 0 to 2. Okay? Now look, here I'm plugging in x values that are between 0 and 2. That's going to be this right here when x is less than 2. Notice you guys here, x is less than 2. So I'm going to be using this function right here, which is x squared dx, and then plus the other part, 2 to 4, so I'm going to go 2 to 4, and you guys, if x is bigger than or equal to 2, that's this right here, right? So that's going to be this function, 6 minus x dx. Okay, now I'm going to evaluate both of these integrals, add them together, and then that'll give me my answer. So let's go ahead and do that. So the integral of x squared is x cubed over 3, and I'm evaluating that from 0 to 2. Plus, the integral of 6 is 6x. The integral of negative x is negative x squared over 2. And I'm evaluating that from 2 to 4. Okay? So, yes, this is about double the work, but it is what it is. Okay? So, again, on this one, I'm going to have a top minus a bottom. So, let's go ahead and do that. If I plug the top in, 2 cubed is 8. So, this will be 8 over 3. If I plug the bottom in, 0 cubed is 0, 0 over anything is 0. So you guys, basically this is wiped out, and I'm just left with an 8 over 3 for that particular integral, okay? Then I have this plus sign, okay, and let's do this one. I'm going to do another top minus bottom, okay? So if I plug the top in this time, 6 times 4 is 24, minus 4 squared is 16, divided by 2 is 8. Okay, then I have a minus, and if I plug the 2 in, 6 times 2 is 12, minus if I plug the 2 into here, 2 squared is 4, 4 divided by 2 is 2. So that didn't come out so bad. So let's see what this red part is. So 24 minus 8, that equals 16, minus 12 minus 2, which is 10. So here I have my final answer, which is going to be 8 over 3 plus 16 minus 10, which is 6. And you guys, again, I need to know how to add fractions together, right? So I need a common denominator, so let's multiply this by 3. Wow, this became really colorful. So it's 8 over 3 plus 18 over 3, which ends up being 26 over 3. All right, so that what did we just calculate? We just calculate that this whole area under the curve here is going to be 26 over 3. All right, let's try another one, and I'll show you kind of a funky one. Okay, example 3. So here we have another one. And you guys, if you're like, hey, I want to try this by myself, maybe turn off the video and give it a shot and see if you can get it. So here, g of x is 1, where x is greater than or equal to 1, and g of x is 2x minus 1, where x is less than 1. And what I want to find on this one, I want to find the integral from 0 to 3 of g of x. Okay, so the first thing I want to ask myself is, where does g of x split? So g of x splits at x equals, can you guys answer the question? Think about it. Okay, if you said 1, you are correct. So it splits at x equals 1. So let's see what this thing looks like. I'm finding the integral from 0 to 3, but it's going to split at 1. So the two integrals I'm taking are 0 to 1 and then 1 to 3. Okay, so let's go ahead and write this. So this is going to be the integral from 0 to 1. Now I want to pick all the numbers between 0 and 1. You guys, this time it's not always going to be the top function. It's going to be this one. Look, notice that x is less than 1. All the numbers less than 1. So I want this one, which means I want this function. So 2x minus 1 dx. And then plus this little part, integral from 1 to 3. And again, 1 to 3, that's numbers bigger than 1. So I want x is bigger than or equal to 1. So it's just going to be 1 dx. Okay, now let's go ahead and try to integrate these. So I know that the integral of 2x is 2x squared over 2, or just x squared. The integral of 1 is just x, and I'm evaluating that from 0 to 1. And then plus the integral of 1 is just x, and I'm evaluating that from 1 to 3. Okay, so doing a top minus bottom here. If I plug in the 1, that's going to be 1 squared, which is 1, minus, and then if I put in a 1 there, I'm going to get a 1. And then if I put the 0 in, that's going to be 0 minus 0. This is kind of interesting. 1 minus 1 is 0. 0 minus 0 is also 0. You guys, both of these guys got wiped out. I've got nothing, okay, which is fine. And then I have a plus, and then if I plug this in, so I'm going to do a top minus a bottom. If I plug the 3 into the x, I'm going to get 3. If I plug the 1 into the x, I'm going to get minus 1. So 3 minus 1 is just 2. 0 plus 2 is going to be 2. So the area under this curve is going to equal 2. All right? Now let me show you a funky one that we haven't seen yet. This is not even a piecewise function, but it does occur on your homework assignment, so let's do it. What if I had the integral from 0 to 2 of 3 to the x dx? Okay, so you guys, this is one of those funky ones. If you had the integral of a to the x, that equals a to the x over the ln of a. Do you guys remember that? Hey, let's review some other ones. The integral of e to the x is what? E to the x. Good job if you said it that. And what about the integral of 1 over x? What is that? That's the ln of absolute value of x. So those are kind of like your weird ones. And then, of course, you have to know your trig ones. But this is what we're using here. Okay, so look, if I go ahead and integrate that, okay, your a is like representing the 3 here, right? So this would be 3 to the x all over the ln of 3. And then I'm evaluating that from 0 to 2. Okay, let's draw a little template here. So I'm going to have top minus bottom. If I plug the 2 into here, I'm going to get 3 squared, which is 9 over ln of 3. And then if I plug the bottom in, 3 to the 0, hey, remember 3 to the 0 equals 1, right? Anything to the 0 power equals 1, so this is going to be 1 over the ln of 3. Now, if I remove these parentheses, something kind of funky here. I have 9 over ln of 3 minus 1 over ln of 3. Can I do anything else with this? Well, I can because I have a common denominator. You guys, ln of 3 is just a number. It's like a weird decimal that I don't really know what it is, but it's just a decimal. So then I could just go 9 minus 1 on the top, which is going to be 8. So my final answer is going to be 8 over the ln of 3. All right, so I hope that wasn't too bad or too long. There's a worksheet that the substitute should pass out to you guys. If for some reason it's not here or, I don't know, something happened to it, it is posted on Google Classroom as well. Okay, I hope you have a good day and I'll see you guys tomorrow. Bye.